Now, why splatting works well? So see, in splatting, there is no need for joining any geometries. So no mesh connectivity is needed. Naturally smooth surfaces we will get. It's a continuous representation and it works well with optimization. It works very well with optimization because in for optimization we need smooth surfaces. It has to be continuous. And see one more very interesting thing, like it works well with optimization. See, the idea is that when we will be optimizing, what we will be doing is that for every 3D Gaussian, we will be tweaking the parameters. We will be tweaking its position, the covariance. We will be tweaking the opacity and the color. And we'll keep on tweaking until the real image, until the rendered image is very similar to that of the real image. And what will happen is that when we'll tweak the parameters of a 3D Gaussian, it will contribute, it will reflect in the rendered image. It will reflect in the rendered image. And hence, splatting technique, it works very well with the optimization. It makes sense also, like millions of uh, 3D Gaussians, if we tweak their parameters, if we keep on changing the look and feel, the size, shape, orientation, it will affect the image, the generated image. And we'll keep on doing it until the rendered image is very similar to that of the original image. So splatting, it works very well with optimization.